Okay, you should have out your lecture notes for lecture 14, experiments, sample spaces, and events. We're heading towards inferential statistics. In order to get to inferential statistics, we have to study a little bit of what we call random variable theory. To get to random variable theory, we have to study a little bit of probability theory. And to get to probability theory, we have to learn a few basic concepts and definitions, and that's what we're going to talk about now. All right, so first off, we have definition. Let me check, I'm looking good here. Okay, I'm not outside of a margin or anything like that. A random experiment, and from here on out, we'll probably just say experiment. We don't usually put the word random in, it's understood. A random experiment is a procedure or action that leads to a result or results that is not predetermined. Okay, I don't want to say any more about that because I want to just move on and put a couple more definitions up. Then we'll look at a couple of examples, and I think it'll be really clear. An outcome, so definition, an outcome of a random experiment is a single specific possible result. Okay, so I'm talking about the results here. These are not exactly the definitions you might see in a textbook. They are good working definitions that will serve us well. So we think of an outcome as just a single specific possible result from an experiment, and let's say the sample space for a given experiment. We usually use the letter S. The sample space S to represent the sample space is the set of all possible outcomes of the experiment. Okay, let's just jump to an example. Example 1. The experiment is toss a fair die. Yeah, I fit all that on. All right, so obviously I toss a fair die, and the outcome is certainly not predetermined, because what am I going to do? I'm going to observe. The outcomes are what we observe when we perform the experiment. The outcomes are the numbers facing up. So I should say an outcome is the number facing up every time I perform the experiment. So what is the sample space S? Of course, it's a set of all possible outcomes. 1, 2, 3, 4, 5, and 6. Obviously. Okay, example 2. Suppose we have, this is slightly contrived just to make it a little bit easy to see. Suppose we have a 2-foot by 2-foot square dartboard. Dartboard, I think I can get that all on. Okay, suppose I have a 2-foot by 2-foot square dartboard, and the experiment is toss a dart at the board. Okay, an outcome is just the point on the board where it lands. Assuming it lands on the board. Where the dart lands, yeah, just about going off the edge there. Well, what's the sample space? The sample space equals set of all points on the board, right? Set of all points on the board. So if I think of the sample space, you know, I can't list them all out because there's infinitely many of them, but you know, here's 2 feet, here's 2 feet, and I'm thinking of all possible points, right, where the dart could land. Okay, et cetera, et cetera, et cetera. All right. Definition. We'll come back to these 2 examples when we look at some other things. Definition. An event, we'll give it a name, E, is, what is an event? If you think of the word event, you realize it's just something that happened, right? Okay, that's just the simple definition of what an event is. And that's really what we mean here. But we have to think of it in the context of the particular experiment we're doing. So what it means is some outcome or possible set of outcomes happened, right? So we would just say something that happened. That is, E, the event, is a subset of S, all right? The event E is a subset of the sample space of all possible outcomes. And I want to do a couple of examples. I've run out of room, but I think because I'm using these new markers, I can rub through here pretty quickly and we can get some, excuse me there, examples up here without too much effort. Okay, let me change color and then we'll keep everything separate and clear. Okay, so first example. Example 1. So the experiment is toss a fair die. S was, all right, S was that set. Let's let the event E be, when we toss it, we get a 3. Okay, well, that is where I am telling you what happened. Hey, I got a 3. But as a subset of S, of course, we would write it like this. E is just the set containing 3. Right? Let's look at another event. Let's call it F. Event F is get an even number. All right, so there I've just told you, hey, I tossed the die and I got an even number. I'm telling you what happened. At least at some level, I'm telling you what happened. Well, F, as a subset of the sample space, would be 2, 4, or 6. If I tossed the die and said, hey, I got an even number, you would know that that meant I got a 2, or I got a 4, or I got a 6. You wouldn't know which one, but you'd know I got one of those possible outcomes in that set. Let's do another example. Event G is get a number. I should have written a pound sign for number. Get a number. I'm going to say, use that symbol, which means greater than. Get a number greater than 2. All right, if I toss the die and I tell you, hey, I got a number greater than 2, you can tell me I must have gotten 3, 4, 5, or 6, right? So as a subset of the sample space of all possible outcomes, there is my event E. All right, from example 2, so the experiment from the example 2 for explaining sample spaces, the experiment is toss a dart at 2 foot by 2 foot square dartboard. Okay, let's just say E. So you know, again, S is the whole dartboard, right? all the different points on the dartboard. Okay, let's let E be, I landed in the upper left-hand quadrant. The dart landed in upper left-hand quadrant. Okay, as a subset of the set S, then we have, let me draw all of S here. And so this is, 2 foot by 2 foot again. So this is 2 foot and this is 2 foot, like up here, 2 foot, 2 foot. But the upper left-hand quadrant, the upper left-hand 1/4, right? That right there is what I mean by E. It is a subset of the sample space of all possible outcomes. All right, we'll stop there.